In previous videos, I showed you how you can configure HSRP, multiple HSRP, VRRP, and multiple VRRP. And I told you that these protocols are going to use only one of the routers as the active router forwarder, and the rest of the routers are going to be in a standby mode, which is a waste of the resources that we have here. What I'm going to configure here is Gateway Load Balancing Protocol, or GLBP. This is Cisco specific, but it doesn't mean that other vendors do not implement this in their routers. But this is not a standard, so you do not really see this in production. But again, because of the features that it has, it is very much desired in different production environments. So what does GLBP means? As you can see, it does load balance between all the routers. All the routers are going to be utilized for what we have here. One of the routers is going to take the role of responding to the request from the computers or other devices in the network, which means that this router is going to decide which router is going to be the exit point for this specific computer. So what it does, as a matter of fact, is this. Let's go to the topology and explain it here. So let's say that I have three routers here, router 1, 2, and 3. And all of them are going to be utilized using GLBP. Let's say that router 1 is going to take the role of active virtual gateway. What does it mean? If PC1 sends a ARP request for router 1 has a virtual IP address, right? That was 10.10.123, let's say 254. And using DHCP, we have assigned this to all computers in our network. And the computer is going to resolve this and get a MAC address, so it is going to send an ARP message. Router 1, which is the active virtual gateway, this is going to be the responder from the whole group. So all the routers are in one group here. Let's say group 1, for example. Router 1 is going to say, for example, this is the MAC address that you need to send your, put it in your frames. So first, maybe router 2 is going to be the MAC address, or the MAC address can be for router 2, or MAC address can be for router 3, doesn't matter, or for router 1 itself. But this is going to be the decision that router 1 is going to make. The next thing is active virtual forwarder. As a matter of fact, all the routers are going to be in forwarding mode, so all routers are going to be active virtual forwarder. If you see that one of the routers is not forwarding, there must be a problem, and you need to troubleshoot that. So how can I make sure that, for example, router 1 in my case is going to be the gateway? The gateway is decided by priority. So if I set a higher priority for one of the routers, that's going to be the active virtual gateway that's going to respond to the ARP messages from the whole network. But the rest of the routers, and of course the active virtual gateway, all of them should be in forwarding mode. The other interesting features that we have here in GLBP, and you do not really see this in other protocols, because in other protocols, as a matter of fact, only one of the routers is going to be in forwarding mode. But here, we have all the routers in forwarding mode. So that feature is going to be load balancing. And this means that I can decide how many packets are going to be handled by which router. There are three different forms of load balancing. The default one is round robin, which means that, let's say that I have three routers, router 1, router 2, router 3, and active virtual forwarder, as a matter of fact, is active virtual gateway. As a matter of fact, it's something virtual. We do not really have it here. So this is going to send the first request to router 1, the second one to router 2, the third one to router 3, then the fourth one to router 1, fifth one to router 2, sixth one to router 3, and this goes on and on and on. This is kind of a round robin thing. What about host dependent? So based on the MAC address that we have, we can create a hash or something, and based on that we can decide which one of the routers is going to be the responding one. So that is kind of a random thing, but not actually completely random. What about weighted? Weighted is very important here. Let's say that router 2 is the one with the most resources in my network. It has more bandwidth, more RAM, more CPU, so router 2 is going to be the most powerful one here. So I will say router 2 should handle more packets than router 1 and router 3. How can I say that? With a proportion that is going to be decided by a value between 1 to 255, 54 as a matter of fact. So I would say, for example, router 2 is very strong, so I'm going to assign it a value of 200. Router 3 is a normal one with an average bandwidth available for that. So that's going to receive the default weight, which is 100. And router 1 is a little more powerful than router 3, but less powerful than router 2. I'm going to assign it 150. It means that now, based on the proportion that we have, for each 3 packets which is forwarded by router 1, 4 packets are going to be forwarded by router 2, but only 2 packets are going to be forwarded by router 3. So this is what weighted means. So let's go for the configuration. Configuration is pretty much the same as what we have in, let's say, a VRRP or HSRP. So what I'm going to do here is to go to configuration mode, go to interface Ethernet 00, and first of all, I'm going to remove the configuration that I had before. No standby 1, no VRRP1. I'm not so sure which one I have configured before, but one of them should be there. And I'm going to start with configuration of GLBP. So I just said GLBP and then the group number. Interestingly, we have 1024 group numbers available here. But interestingly, only one of them is going to be necessary because we are not going to configure multiple GLBP unless there are some specific scenarios which we are going to cover, of course, in the next session. So I'm going to go with group number 1 for here. And then it says what is the virtual IP that you are going to have. So I'm going to assign an IP of 10.10.123.254, which is exactly what we had for previous ones. And this is the one which is assigned to the computers using DHCP in our network. Then I'm going to configure some more things. On router 1, this is going to be the active virtual gateway. So I'm going to set a higher priority for this. So I just say the priority is 150, for example, here. Also, I needed to say that this router is a little more powerful than an average router. So I'm going to give a weighting of 150 to this. Now that I have assigned weighting, I need to tell the router to use weighting as the deciding factor for load balancing. So what I need to do is to say load balancing is going to be weighted. So hit enter. Also, one thing that I pretty much like to do is to enable preemption. I'm not so sure if it is enabled by default. So this is router 1. Let's go to router 2 and do the configuration here. So again, enconf interface Ethernet 00, no standby 1, no VRRP1, GLBP 1, IP is going to be 10.10.123.254. That's going to have a priority of 120, which means that if router 1 fails for some reason, this is going to be the active virtual forwarder for my group. It's going to have GLBP1 is going to have a weight of 200. It's going to use weighting. Also, it's going to preempt. And that is the configuration that I have here. And let's do this on router 3 as well. So en configuration interface Ethernet 00, no standby 1, no VRRP1, GLBP 1, IP 10.10.123.254. Also, I need to have a weight of 100. Of course, I can just leave it alone because the default is 100. I do not really need this command, but let's say that I have done this. Preemption is enabled, and the priority is going to be the default one, and also GLBP1. The load balancing is going to be weighted. So let's verify. Show running configuration of interface Ethernet 00 says that GLBP is configured here. I need to wait for GLBP to start working. And on router 2, show run interface Ethernet 00. This is the configuration that I have here. Very nice. And let's go to router 1. Show run interface Ethernet 00. And this is the configuration that I have. Now you see that on this router, we have started the process. I need to wait for the other routers to join to the group and then do the actual verification. If it takes some time, I need to make sure that they are all pingable. 1 and 3. Yes, they are available. So I just need to wait for that to happen. And then I'm going to type show GLBP. Okay, it has already happened. So you can see that it says on router 2, for example, it says it is standby, which means that this is not the active virtual gateway. Router 1 is the active virtual gateway. The other important thing here is says standby is local. That's okay. The priority is 120. That is what we did here. Waiting is 200, and also we have used this load balancing as the load balancing that we need to have. So there are 3 forwarders, which means that all of the routers are in forwarding mode. All of them are active. You see that forwarder 1 is active. No, this one is for AVG as a matter of fact. This is forward. They are forwarding. All of them are in forwarding mode. This means that it is not the actual gateway. This one as well. Also, what is important here is the preemption, which is enabled, and the waiting, which is configured for all of them, are here. So you see that this is the actual verification that we needed to do, and everything seems to be working just fine.